Video we'll be covering biomolecules. Biomolecules is the most very high weightage chapter and free marks. So the first paragraph this is surprisingly nothing. The second paragraph has carbohydrates are primarily produced by plants and form a very large group of naturally occurring organic compounds. Some common example of carbohydrates are cane sugar, glucose, starch. So example, like we have the formula of carbohydrates which is CH2OY. Glucose fits it, but acetic acid as well, so it's not always true. And ramnose does not fit this formula. Even C6H12O5, um, like that is ramnose. That doesn't fit this definition. They contain specific functional groups. They be defined as optically active polyhydroxy aldehydes or ketones, which produce such units on hydrolysis. So we have classification of carbohydrates. Monosaccharides are carbohydrates that cannot be hydrolyzed further to give simpler unit of polyhydroxyaldehyde. About 20 monosaccharides are known to occur. Examples are glucose, fructose, ribose. So here they talk about oligosaccharides. They yield 2 to 10 monosaccharide units on hydrolysis. Disaccharides and trisaccharides and tetrasaccharides are their classifications. And and yeah, it basically depends on number of monosaccharides formed on hydrolysis. Most common is disaccharide. See, polysaccharides are not sweet in taste. Polysaccharides are not sweet in taste. These two oligosaccharides or monosaccharides may be sweet in taste, but polysaccharides is not sweet in taste. Please make sure you mark this up. Polysaccharides are not sweet in taste because you can relate it like this. Example is gum, starch, cellulose, glucose. I mean glycogen, and I don't think cellulose is gonna taste sweet, lil bro. All monosaccharides with aldose or ketose are reducing sugars. See, the triose, tetrose also counts the carbon of the aldehyde. Okay, so it's called aldotriose when you have three carbons, aldotetrose, aldopentose, aldohexose, aldoheptose. Same for ketones. So freely occurring in nature is glucose. We are studying about glucose now. Now we have preparation of, and it also present in ripe grapes. Okay, preparation of glucose is from sucrose. Okay, so if you boil sucrose with HCl, dilute HCl or H2SO4 in alcoholic solution, glucose and fructose are obtained in equal amounts. So basically, what we're doing is we're taking sucrose, we're boiling it with dilute HCl or H2SO4 in alcoholic solution, and they are obtained in equal amounts. Keyword on equal amounts because regular hydrolysis, like okay, no, it's equal amounts itself, but like just remember equal amounts. They can have commercial preparation of glucose, which is boiling it with hydrolysis of starch. Okay, boiling it with dilute H2SO4 at 393 Kelvin under 2 to 3 atmospheric pressure. It can be done by starch or cellulose. So this C6H5 H10O5N plus NH2O in presence of H plus 393 Kelvin 2 to 3 atm gives glucose. Glucose is also known as dextrose. Glucose is also known as dextrose. It's the monomer of many large carbohydrates. Evidence of glucose structure is given here. Molecular formula, so we know prolonged heating with HI, it forms N-hexane, okay? And it suggests it's a test that all the six carbons are linked in the straight chain. Okay, remember the tests also because they will ask that. Glucose reacts with hydroxylamine, okay, hydroxylamine to form oxime, and adds a mole of hydrogen cyanide to give cyanohydrin. Okay, cyanohydrin. These reactions confirm the presence of a carbonyl group. So this is the test for C double bond O group, oxime or cyanohydrin formation. So test for the aldehydic group is using a mild oxidizing agent like bromine water. So it forms gluconic acid. One of them gets fucked. But more importantly, it's a test that the carbonyl group is present. It's the test that the carbonyl group is present as an aldehyde group. Previously, we had just tested for the C double bond O group, but now we have to test for the aldehyde group. Acetylation gives glucose pentaacetate. Glucose pentaacetate. Everything except the top one. Alright, because it has five OH groups, correct? So whatever OH groups is there, it'll get cut. So it basically it's for the presence of five OH groups. It's a test for the five OH groups, and it exists as a stable compound. It's a stable compound. On oxidation with nitric acid, glucose as well as gluconic acid yield a dicarboxylic acid, which is called sacharic acid. It's indicating the presence of primary alcohol group in glucose. Oh my god. It's indicating the presence of primary alcohol group in glucose. So once I'll be summarizing the tests. First test for carbon atoms, which we know. Second test is for test for C double bond O group, which we use oxime and cyanohydrin. Third test is test for aldehyde group, where we use Br2 water as an oxidizing agent. Fourth test is for test for 5 OH groups present. Fifth test is test for the primary alcoholic group. Primary alcoholic group, because we are oxidizing this as well. So glucose is always D plus glucose. So we have um like they're just talking about deconfiguration. They're confusing us. Don't look at this. It'll make you think that OH on the left side is minus sign. It's not. Plus and minus talk about the, what do you say, optical rotation of the system. But here this is D because it's the right side of the OH group, and this is L because it is left side of the OH group. The structure of glucose and glyceraldehyde is written in a way that, what do you say, the most oxidized carbon, which is CHOs at the top. This is called golden fissure, if you guys remember. Look, also one extra point, it doesn't perform 2,4-DNP, which is Brady's reagent. So basically, despite having the aldehyde group, glucose does not give Schiff's test. It does not give Schiff's test, and it does not form the hydrogen sulfide addition product. Okay, does not form the hydrogen sulfide addition product with NaHSO3. I hope you remember that. So so the pentaacetate of glucose, okay, that does not react with this thing, hydroxylamine, pentaacetate. Where have we seen that before? It's this one. Pentaacetate does not react because, see, when it forms the cyclic structure and then you do acetylation, it'll form pentaacetate, right? So they're talking about that itself. They're not talking about the normal CHO group. So still remember, the pentaacetate of glucose does not react with hydroxylamine, indicating the absence of free CHO group. So this is a very important paragraph. Two different crystalline forms are obtained. Alpha form of glucose is obtained by crystallization from concentrated solution, while beta is required from crystallization of hot saturated aqueous solution. Saturated aqueous, which is also concentrated, obviously, but it's hot. That's the difference. And the melting point of alpha is less than melting point of beta glucose. So as you guys can see, these two forms, right? These two forms, they exist in equilibrium, alpha and beta. And just to rack your brain, alpha melting point is less than beta. Alpha is formed by saturated solution, while beta is formed by saturated hot solution. And crystalline, obviously, crystallization. So they're talking about this carbon being switched up for beta and alpha, and yeah, that is called your anomers, and they are analogical to pyranose structure, the six-membered ring of glucose, in analogy with pyran. Okay, basically it's pyran, right? So pyran is cyclic organic compound with one oxygen atom and five carbon atoms. So cyclic structure, most correctly represent Hayward structure. It's called Hayward structure. This is called. So the trick for this is, first you draw your alpha glucose, which is in this direction, and then you just attack this like this. So alpha glucose, your attack, and that forms your hem. your Haworth structure, which you can easily draw after that. Beta, you switch up the first position and then you connect it. Fructose is, however, an important ketohexose. It's obtained by the hydrolysis of the disaccharide sucrose. In its pure form, it's used as sweetener. Fructose is majorly a laboratory compound. It's found experimentally and it belongs to D series, which means it looks somewhat like this, bro. I'm telling you, mug the structure of fructose. So, similarly to glucose, we have two OH on the right, then one left, then C double bond O, then your primary alcohol. So yeah, this is nothing but furanose, like furanose structure of fructose, which is called fructofuranose. Like that in your yeah. So we have to remember and beta structures of furanose. So we had learned that alpha is when OH is on the right side. So same thing will be following here. OH is on the right side for alpha and beta OH is on the left side. That's all. So first we have disaccharides. From here, I'll be going a little faster. Um, they're formed by an oxide linkage between two monosaccharide units through an oxygen atom. It's called glycosidic linkage. So in sucrose, the aldehydic or ketonic group of the monosaccharides are bonded. Therefore, they are called non-reducing sugars. But um, in like maltose and lactose, the functional groups are free. Therefore, they are called reducing sugars. Like that. It gives equimolar mixture, sucrose, upon hydrolysis, obviously. C1C2 C1C2 glycosidic linkage in um, sucrose.